Hello, and welcome to this episode of the Geotechnical Engineering Podcast. In today's episode, I'm talking with Dr. Ashley Cabas, Ph.D., member, M.ASCE, assistant professor at North Carolina State University. We'll be talking about the importance of understanding local soil conditions for building safer infrastructure. We'll also be talking about the dynamics of soil and rock behavior under cyclic loading, and we'll be talking about advancements in seismic hazard assessments. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, here's a quick word from our sponsor for today's episode, that being Tensar, a division of CMC.
Check out Tensar Plus, the award-winning design software for construction professionals to design with geosynthetics and calculate their value on projects. Tensar Plus is simple to use with a powerful engineering system at its core. It leverages our decades of research and experience with soils all over the world, so you can count on your solutions working the first time, even in the most difficult conditions. Whether you're designing a crane pad or need to build a temporary road over muck, the cost, time, and carbon savings can be calculated, making comparison with alternatives simple. Specs, reports, and product data can be generated for your design, and training resources, research, and our third-party expert reviews are all provided conveniently in the software if needed. Usable both online and offline, the app is available in browser and on all major mobile platforms. Whatever you're working on, Tensar Plus is your toolbox for success.
All right, Dr. Cabas, how are you doing?
I'm doing great. How are you?
I'm well. Thank you so much for coming on. I was really looking forward to this conversation, and I'm glad that we have you here on the podcast. So this should be fun.
So I'm very happy to be here, and thanks for the invitation.
Excellent. So, Dr. Cabas, how did your journey in civil engineering begin, and what led you to specialize in on the geotechnical aspects of earthquake engineering? How did you get there?
Well, my mom studied civil engineering, and my dad is a mechanical engineer.
Okay.
But I did not want to go into civil engineering just because of my parents' influence. And I should say there's nothing wrong with that. For people, I know many people felt inspired by their parents. I did as well, but that wasn't enough for me. I really wanted to make sure I took a deeper dive into what I really wanted to do. So I went to my parents' alma mater. It's called Universidad Central de Venezuela in Caracas. And I conducted interviews to people. I went to, of course, the civil engineering department. I talked to civil engineer students. I talked to electrical engineering students, and I went to the Department of Economics, because those were the three, fields that I liked. And there was something about the labs, I have to say. I love the hydraulics lab. I love talking to the seemingly more just talkative and collaborative people in civil engineering than in the other two areas. And there was something about conversations going into very tangible, like civil infrastructure. They could point it to the very impact of their profession that I loved. So that I was sold for civil engineer. I was like, that is my thing. And then I think that as an undergrad, I really fell in love with how complex soil mechanics is. And I really like all the uncertainty associated with geotechnical engineering analysis. So that was that. And then I would say that I loved geotechnical earthquake engineering because of Adrian Rodriguez-Marek, my Ph.D. advisor at Virginia Tech. I have to say that I thought I was going to become a deep foundations person or a slope stability person. But then I didn't know at the time, but Adrian arrived to Virginia Tech at the same time I started my master's. And when I learned about what he did for research, I just felt like my skill set was so far away from probabilistic seismic hazard analysis and large ground motion databases. I was like, I'm not ready for that. And taking his classes was a big challenge for sure. But also he had this and still has this passion for earthquake engineering that is just contagious. So I think that I didn't realize that, and I really found myself enjoying all our conversations. Everything related to earthquake engineering became my passion as well. So I guess I was meant to be a geotech earthquake engineering person.
Well, that's great. I mean, it's interesting. I talk to people all the time, right? And some people have no idea what engineering is, and then they end up here. And then there are others that, I knew I wanted to be here, but it's very interesting that we all kind of end up here. and it sounds like, thinking that you weren't ready to end up in the seismic aspects, the professor had a lot to do with that as far as explaining it in a way that, like you said, is contagious. That's powerful. That's powerful for anybody that's listening. And it's a professor, you can make a big impact on somebody's life.
You have no idea. And I think, Jared, it was equal parts his enthusiasm and his patience as I was going through my learning process. I felt challenged in a good way, but I also felt supported. And I feel like that combination really made it work for me, because I felt like there were steps that I could follow so that I learned what I had to learn. I realized that I could do hard things, that I just had to work my way through them, practice, ask questions. It wasn't this mysterious box that only geniuses can understand. So the fact that he made it accessible I think it was a game changer for me.
Excellent. And I'm certain you incorporate those aspects into the way you teach, right?
I try my best to emulate that. Absolutely.
Excellent. So how do local soil conditions affect ground shaking during earthquakes? And also, why is it important to understand this in order to have safer infrastructure? Now, local and regional conditions for soil conditions and seismic hazard risk, there's a lot that goes into that. Some of the folks that are listening in are seismic experts, but some are students that have no idea. They haven't seen the class yet. So what can you tell us about the importance here?
Oh, this is music to my ears.
Go for it. Unpack it and take your time, Doc.
Get ready for your sign effects crash course now.
All right.
So let's just start by defining what we mean by site, right? Effects. So I'm talking about soils and rocks, so earth materials, and I like to refer to them as either shallow or deep geologic structures, right? It's just a terminology that allows us to think more broadly and not just sands and clays, right? So when we think about that shallow and deep geologic structure, we want to understand how they can affect ground shaking, because ultimately that will be the seismic demand on whatever civil infrastructure system that we are analyzing. So these local site conditions can affect them in three important ways. They can change the amplitude of seismic waves, they can amplify them, but also de-amplify them, and they can change the frequency, content, and duration of ground motion or ground shaking. These three aspects or characteristics of ground shaking are super important. Amplitude, let's start with that, is the easiest one. The larger the amplitude, the more damage it can cause, right? We're talking about larger forces or larger accelerations. This can definitely impact or be detrimental to the performance of civil infrastructure systems. Frequency content can be a little bit more tricky, but if you think about how different structures respond differently at different frequencies, then it really becomes important for us to understand, once the earthquake happens and seismic waves are produced, how that seismic energy is distributed across all those different frequencies. Because if it just so happens that we have most of our energy in a frequency band that can really excite our systems and enhance that response, then we need to know. We need to know how to design our structures for that specific demand within those bands. And then duration is also an important one. Duration matters because for systems that degrade, as they, let's say, enter in a nonlinear response, they accumulate displacements or deformation. You can think about the buildup of excess forward pressures, for example, for geotechnical systems or loose saturated sands. Or we can also think about any structural element that undergoes that deformation as more cycles of loading are imposed. Then duration matters. And duration has proven to be proportional to the size of the earthquake. So the larger the magnitude of the earthquake, typically we get longer durations. But soils, again, that local structure, the geological structure, can also impact duration, lengthening the amount of time that the system will undergo this strong ground shaking. So again, how these geologic structures can change those three characteristics are really important for building safety.
Excellent, excellent. And what do you think is the most surprising finding about dynamic behavior of soils or rocks under cyclic loading that you come across in your work?
That it changes with orientation.
There you go.
Nobody tells well, like this I wasn't aware of this. You understand that ground motions, their intensity, it can change with orientation, right? But then recently in our work, I think we've been some of the first ones to point to places or site conditions that really enable a stronger relationship between azimuth or orientation and specific properties and resulting ground motion intensities at the ground surface, which was pretty surprising and exciting for us to see. It means that we have to figure out or make sure we understand those critical properties and which direction. The mechanism behind it has to do with anisotropies in the soil, changes in fabric, which we know from the soil mechanics perspective. We understand from even engineering geology perspective that these materials will undergo different processes. If you think about the positional processes, there are certain rocks that have this anisotropies already. So even thinking about parent rocks and how they weather over time, there are multiple anisotropies that may perfectly well lead to a change in these properties with orientation. So it's something that we don't talk a lot about on the engineering, earthquake engineering side, but our team is very excited to really understand the mechanisms, how we can identify site conditions that, raise that flag, like, okay, be careful because maybe here you have to do a little bit more in-depth analysis to understand what's the critical property, for example. So that has been super exciting for us too.
Oh, that's great. That's great. So it's a challenge, but it's an opportunity, especially from a research standpoint, right?
Absolutely, yeah.
Excellent, excellent. Let's talk about seismic hazards, the assessment of seismic hazards. What tools or technologies do you find most effective? And I know it probably depends, but what are some of the things that you're leaning upon?
Well, I will say that because having large magnitude event or a damaging earthquake at a particular site multiple times is rather infrequent, right? It's not likely. We cannot rely on history or past observations. That they become a poor indicator of what can happen. So that means that we need to really understand earthquake processes well and have frameworks to quantify the uncertainties that are associated with the process. Basically, if we could just stand in a place in our project site and have a sensor and say, okay, I'm going to measure exactly what my seismic demand is, you will have to wait there for that design level earthquake to happen for you to record it and then use it, right? Which is obviously not possible. Then we go to the best next thing. Well, what about nearby? What has been recorded nearby? We get into issues like spatial variability of soil conditions. What are the actual contributions at your site versus the site where that recording station was, for example? And then the fact that we cannot predict future events, right? So there has to be a way, and there is, spoiler alert, a way for us to really, in a rational way, combine all potential sources at different distances, at different site conditions that will affect the variability of ground shaking that we will see at our site. And that is no other than the probabilistic seismic hazard analysis. And I think that has become a great tool for just decision-making in terms of uncertainty, in terms of understanding the probability of exceeding a set of ground motion intensity measures. And then you have as a designer, you have the opportunity to understand, well, which intensity measure would be more important to characterize for a specific piece of civil infrastructure. And I will say that USGS provides amazing products that allows practitioners to understand hazards really well in the US. I'm talking about the National Seismic Hazard Model and the core machine, the engine that allows those outcomes or products for us to use is PSHA. So that would be my recommended procedure framework to think about seismic hazards for sure.
Excellent. Thank you for that. Can you share some insights into the relationship between ground motion characteristics and the performance of civil infrastructure as it relates to what happens during an earthquake? I think that'll be helpful for folks as well.
Yeah, absolutely. And I really try to highlight this in my classes because I think it brings the message home. So especially with regards to that frequency content that I was discussing earlier. So let's say we start with the bridge. Bridge tend to be what we call long period structures. So they resonate or they respond more to long period motion, meaning what this means on the ground motion side is that you want to look at a ground motion that has a lot of that seismic energy concentrated in the long periods, because that one will be most detrimental to the performance of that bridge. In contrast, if you're looking at, let's say, a 2-story building, kind of just a short infrastructure, kind of chubby, it will resonate with what we call shorter periods or high frequency. So it will have kind of like this motion, versus a tall, slender structure will have more of a longer period response. So that gives you that relationship should hint what type of ground motions would be more important to subject your structure to make sure it would be safe when an earthquake happens. So that's a quick difference in terms of frequency content, for example.
Excellent. Thank you for that. And what is the role of geotechnical extreme event reconnaissance in advancing research and practice? And this is coming up a lot with all the events that are happening. We got to go out there now. We have to get this information. But what are you seeing there?
Yeah. And you're exactly right. I think that most people will understand the immediate value of documenting case histories and then also collecting perishable data, right? But I think beyond those two, which are absolutely important, and the main reason why we do this, I've been very fortunate to participate in 2 reconnaissance missions myself. My first one after the 2018 Anchorage, Alaska earthquake. And then the second one was a remote one after the 2021 Haiti earthquake. Very different reconnaissance missions, but they highlighted how disproportionate the effects of earthquakes can be on communities. So beyond the case histories, beyond understanding what ground or data sets that are needed to advance research and practice, it really brings the message home that you are affecting communities. And it is not always a function of the ground motion characteristic or the site condition. So it does bring home the message that who's in the building and who is in that community also matters. And we should have that in our minds as we understand all the other technical elements of our designs. The other aspect that I really love about reconnaissance is that it becomes a puzzle. You really need multiple people with different expertise, different backgrounds, because they're all in the field looking at the same damage, the same patterns, if you will, but looking at those slightly differently or from a different perspective. And that's so much needed, not only after extreme events, but in engineering as a whole. If you think about our field, we really have to be able to break from those disciplinary silos where we used to live in geotech or structures, because real problems, real systems do require information and knowledge from multiple disciplines, and especially collaboration across all of those. So in reconnaissance, I think it becomes, again, very, very apparent that just the geotech will not be alone, or just the geotech that focuses on ground motions. I will not get everything right. I really need to understand, ground deformations or different aspects or mechanisms behind that landslide. So I really like that aspect about reconnaissance, and I think that it's good that it percolates to both practice and research. Yeah.
That's great. I mean, it's hard to think of a more collaborative effort that happens than that, right? And you made a very good point that it's not just the engineering aspects. There's a social, cultural, economic. There's so many other things that happen when you're trying to gather this information, when people are trying to gather their lives at the same time, right? It's asking for a lot. So thank you for your service and leadership in this regard. It's
my pleasure. I gain so much from it as well, and I try to involve my students just because. And if you talk to geotechnical earthquake engineers, many of them look back at their reconnaissance missions as defining moments. So I feel like since I was a student, I was craving this opportunity, not because you've also hear senior people saying this is not disaster tourism, and it's definitely not. Like, we should, take this with the, highest responsibility and seriousness, because it is, right? It is a big, important role and service to our profession. But I think as a student, I was craving the opportunity to have that experience and understand, have the deep understanding of the meaning of my analysis back home, or am I getting this response spectrum correctly? Who is this impacting? So yeah, I think if you are your audience, if they are listening, if there is any way for them to get involved, I would highly recommend it. And I know that many associations that lead these reconnaissance missions, they really want to have more practitioners involved, and they again trying to have a myriad of expertise and backgrounds. So it really doesn't have to be only from academia.
Okay. Oh, thank you for that. We'll make sure to get some of that information in the show notes for folks that are listening and watching. So let's talk a little bit about recent advances in earthquake engineering that you're excited about. Now, you hinted at a few things already, but some things you're excited about and how they impact your personal research for your group, your team.
Sure. So yeah, you're right. I already mentioned a few.
All good. You're excited, so you have to share, right?
I'll have to say, yeah, I cannot pick one, so maybe I'll give you two.
Go for as many as you want. That's fine.
That's dangerous. My skin is okay. Just two. And one will be that, especially after my PhD, I did my PhD on site-specific analysis. So this is incorporation of side effects at a given site. So this single site vision. But then as a professor, I started to become more and more curious about system level problems. When you look at a city, this is a portfolio of buildings, not just this one building. And when you look at transportation networks, for example, these systems are interdependent, they are connected. Saving this one building may not be the way to go. Maybe we need to think about what's happening at larger scales. But there I was with a lot of knowledge on how local soils and rocks can affect this one site. So I've been very, very excited that my team is just one of many who are really thinking hard about how can we incorporate the systematic contributions of that local geologic structure at larger scales. How can we incorporate those effects that I mentioned matter so much in terms of amplitude, frequency, content, and duration at, let's say, regional scales? I think that has been very exciting because, at least in our team, it has brought us to bring aspects of geospatial analysis, trying to understand now spatial correlation structures across different either soil conditions or intensity measures that matter for engineering design. So that has been exciting. And then, as you said, the other topic that has been really, really interesting for us is that intersection of engineering aspects, but also exposure and social vulnerability. How can I really bring those together and our expertise, because we're not social scientists, but I've become very, very interested in collaborating with them and bringing those interdisciplinary collaborations to our team so that we have a more holistic view of the disaster. What does it look like, and how my hazard characterization can help improve maybe the recovery of some of these communities after these events. That has been very difficult, but also super, super exciting. Every time we have meetings, we have great collaborators in these topics that help us understand, that help us ask the right questions, I would say. And it has been very intellectually stimulating. We are, super happy to ask the questions and try to find some answers.
Excellent. Sounds challenging, but also sounds very rewarding and meaningful work. So that's great. Yeah. Now, how do you incorporate the findings of your research into the classroom, and what impact do you hope that it has on your students?
Yeah, so for example, Reconnaissance has been a key outcome for me from my research of bringing, and this is not just from me, but multiple teams that go into this type of missions. They produce reports that then I can use as examples in my class. So when I teach side effects, I don't have to only go back to the Mexico City earthquake 1985. I can bring back 2017 Mexico City earthquake too, or Puebla, I think, earthquake, or other examples that are more recent, and then the students can feel like it's more relatable to them. Also bringing my own expertise throughout these missions, I think it can make also the difference in how they connect with me, connect with the material. I've been also incorporating, because of this new research area associated with social vulnerability, there is a NERI institute or center that's called Converge. And they provide amazing training modules. I'll be happy to also give you that website for engineers who are interested. And they have provided amazing resources for us to educate ourselves on these new disciplines so that our collaborations are more effective. So I've incorporated, for example, new homework assignments on that based on their training module and suggested assignments. So it really, they make it so easy for instructors to find the right resources. I think a good compilation of literature that will help students get started. So I'm really taking advantage of all those resources in the classroom, and then just trying to make sure my students have a holistic view of how different disciplines interact. I really, in my practice, I incorporate a lot of engineering seismology aspects in my research. So I try to bring that knowledge to my geotechnical earthquake engineering class, so that the earthquake process, the geology associated with it, the plate tectonics associated with it, my students are very familiar with that and understand what aspects are important for engineering purposes. And now the last piece I'm adding is the other end of the spectrum, where you look at communities and community resilience and ask yourself, oh, okay, after all this great design and probability, how are they, how am I impacting the community that we are meant to serve? So I'm really liking the art that I'm producing for the class. It's very interdisciplinary, which I think is necessary.
That's great. That's great. And I'm sure it makes it more interesting when you see how it ties back to the real world, right? I mean, I think that's so important. So let's change gears a little bit. Let's talk a little bit more. Well, let's talk a little bit about the Earthquake Engineering and Seismology Community Alliance in Latin America and also in the Caribbean. How did you get started with this global engagement program?
Well, thanks for the question. This is my passion project, although it sounds like I have many of...
a lot of passion projects. I'm sure your students will echo the same.
As a parenthesis, I used to start pretty much all my classes like, oh, this is my favorite topic. And now the students won't believe me. It's like, now you said that, you've been saying that for a month now. And I'm like, I know, but, Washington statistics, engineering seismology, and now of course they're all... Anyway, yeah, that happened. But no, Escala, it's called. So that's the acronym for our program, and it's my passion project because it came from my understanding of those disproportionate effects of earthquakes around the globe. I am from Venezuela originally, and it just made me think that I needed to reframe my research questions. I still love earthquake engineering and engineering seismology. I was just wondering if I could reframe it so that I could help the people that need this science the most. So being a Latin American professor, I'm very invested in the Latin American community and in the Caribbean. And it is very clear once you start digging a little deeper that the ground motion data sets are not as exhaustive. There is a lot of data in terms of subsurface characterization. So uncertainties are very large. But that doesn't mean that we cannot do our best to characterize them. In fact, it means the opposite, that we really have to do our best to really quantify it, just because we don't have a lot of data. So that has brought a completely new framework, how I conduct my research. And Escala has given me the ability to create a network of professionals, also from my experience in Reconnaissance, understanding how difficult it is sometimes to connect with people in these places where the earthquake happens. When it happens in Japan or New Zealand, we know exactly who to contact. We have colleagues with networks that are already very strong, and they know exactly, where to find the resources to go get more data. But this is not necessarily the case in different countries in Latin America. So I want Escala to provide that place for professionals and students to learn about each other's work in the region and together try to build community, build capacity to reduce seismic risks. That's the main goal. And along the way, we've designed mentorship programs and working groups that will allow the community to grow together, to communicate more. And it has been an amazingly rewarding experience with just knowing amazing colleagues and seeing that passion that I have for that mission. It's in many, many, many colleagues in the region. So I'm the luckiest person.
I love it. I absolutely love it. Well, before we take our break, final piece of advice you have for engineers that are looking to make a difference in the field of earthquake engineering and beyond. What do you have?
Okay, so I would say not to shy away from learning from other disciplines. So I think it's great to get, our master's degrees and seeking more education. But in doing so, maybe look a little bit around and what's happening in geophysics and physics and geology. Understanding a little bit more of those disciplines can really go a long way in creating really transformational advances in earthquake engineering. And I want to say that I'm not, advocating for shallow knowledge that has a lot of breadth, but rather trying to find a good combination of depth and those, maybe adjacent disciplines that can really enhance your understanding. For me, it has been engineering, seismology, and geotechnical engineering. And the things that we have discovered and just thought about at the interface are amazing, and something that we could not have done had we been siloed just in the geotechnical engineering discipline or just in engineering seismology. So I would definitely, encourage people to do interdisciplinary work, talk to others, go to different conferences and have that friction. I think there's like a healthy friction of ideas that can be really stimulating. Yeah.
Excellent. It's a great note to pause on. We're going to come back in just a minute and close this one out with Dr. Ashley Cabas in our Career Factor Safety End segment. Stick around. All right, welcome back. It's time for our Career Factor Safety End segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? So today, of course, we're speaking with Dr. Ashley Cabas from North Carolina State University. So, Dr. Cabas, you've already had a very successful career. You're in a successful career. When you look back on your career, what's something that you've implemented in your career to give yourself a factor of safety?
Well, I will start by saying that I will encourage people to redefine success in whatever metric they want, redefine hustle, redefine it in your own terms. So I will just say that. And then I study risk, Jared. So factor
I know.
I will encourage people to go for those high risk, high reward, living on the edge of the factor of safety.
Okay.
Because this is why. So, you have a great consultant job and you enjoy it and the company where you are working at is great, but then you're curious about research, about science, then go for it. Go for that, master or even a Ph.D. degree. Talk to people in academia if you like it. And of course, I'm biased. I am making a pitch for, having more people come into grad school. But now, more seriously, I think that there are times in life when you really have to take those risks. And even if you go, below that factor of safety, even if it's a mistake, even if it doesn't go as you plan, I think it's worth going through the process. It's worth getting to know yourself through the process and learning and just standing up just stronger for the next one. So, yeah, I wouldn't play it safe necessarily. For the career,
I love it.
And having said that, of course, there are, things that people can do to make sure they do well, again, in their terms. But yeah, I would say that if there's this point or this even pivot for you, talk to some people, talk to your network, because it might be worth that risk.
I love it. Absolutely love it. Ashley, thank you so much for coming on and sharing all these great insights with us. You share some great information and advice that's been going to be helpful for our listeners and watchers. How can people find you, Professor? What's the best way for them to, your email you want to share? You're on social media. What's the best way for people to find you?
Okay. So I have a website. So maybe you can provide that the link. But if you don't want to, if you're listening and you go to the North Carolina State University website for Civil Engineering Department, you can find my faculty page, and then you will find all the links and my email address as well. I think I'm also on social media on Twitter, although it may be imploding. I don't know. LinkedIn also. I've become a more frequent user just to see and taste the waters. So there as well, you can message me if you need any advice or want to share something interesting of your work.
Excellent. Just like that, it's a wrap. That was great. Thank you so much.
No, that's fine. Thank you. This was really fun.
Yeah. I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as links to the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.